let's use these laws of indices then to help us simplify things. And these are in the textbook around about page 41, 42. What we do to do these things is we can see in this example that I'm effectively multiplying all these terms together. No symbol between the a cubed and the b squared, need to multiply them together. So I'm actually multiplying a cubed by b squared by c by a by b cubed by c to the 5. So where the base is the same, I can actually use the laws of indices. So I can add the powers if I multiply. So I can combine them, a3 times a times b squared times b cubed times c to the 5. And if there are no numbers in an expression, you can either leave nothing there at all or a dot. Often people put in a dot to say multiply. So they're all times together. No power means that the power is 1. So I know that actually this is a to the 1 and that's c to the 1. So then I can use the laws of indices to combine them together. A to the 3 plus 1 is a to the 4. B squared times b cubed is the same as b to the 2 plus 3, which is 5. C to the 6. So all this simplifies down to a cubed, a to the 4, b to the 5, c to the 6, using the first law of indices effectively. So we can use these laws to simplify expressions. Here's another one. A bit further on in the textbook, you see this one. We know that we can have fractions in the power. We also know we can have negative numbers in the power because that's how we'd represent an inverse. So if I wanted to simplify that, I need to be able to add and subtract fractions and add and subtract negative numbers. So in this case, I would collect the a's together. A to the half times a to the 6th times b squared times b to the half times c to the minus 2 times c. So collecting them together, you don't need to write this intermediate step down, but you can see them grouping together. So that means we now have a to the half plus a 6th times b to the 2 plus a half times c to the minus 2 plus 1. So I can do that. This bit needs to be able to add, I need to be able to add fractions, and we've talked about this sort of thing before. We need a common denominator. So what number does 2 and 6 both go into? 6. So I can turn the half into 6ths, which is 3/6. So this becomes a to the 3/6 plus 1/6, and b, 2 plus a half is 2 1/2, but we wouldn't write it as a mixed number like that. 2 is 4 halves, so that's like 4 halves plus a half. And then c, minus 2 plus 1 is minus 1. So now 3/6 plus 1/6 is 4/6. 4/6 simplifies to 2/3. So this becomes a to the 2/3, b to the 5/2, and c to the minus 1. I leave it as an improper fraction like this, 5/2, rather than 2 1/2, because I might want to. I wouldn't necessarily always need to, but then I can write this in root form. The 3 underneath in the a to the 2/3 becomes the cube root of a squared, so I can rewrite this as the cube root of a squared. How can I rewrite the b? Right, the square root of b to the 5, I wouldn't need to put the 2 in, because the square root means it's 2. What about the c to the minus 1? 1 over c, right, the inverse. So I could rewrite this all over c because it's divided by c. So that's another way of writing that. You might want to write it like that, you might not, but it's important to be able to see that you can write it like that and recognize that they're the same things. Okay? It's an exercise. What about this one? To simplify something like this, I recognize that I can actually split the fraction. If we look at an example at the side here, 2 plus 5 over 6, that's 7/6. I can think of that as 2 over 6 plus 5 over 6. I can split the numerator and write each part of the numerator over the denominator. I'll do that here. So I rewrite this as x squared y cubed over xy plus xy squared over xy. So I split that numerator and then write each part over the bottom, or the denominator. And then I can cancel down. I can use the laws of indices or the idea of cancelling to cancel this down. I've got 1x on the bottom in the first term and 2 on the top, so x cancels with one of the x's on the top, leaving just 1x. The y cancels with one of the y's on the top, leaving y squared. Yeah? Josh? Happy? What about the next one? How would that cancel down? You have a y left, exactly. X is cancelled. Y cancels with one of the y's on the top, leaving just y. So this all simplifies down to x y squared plus y. So this simplifies down to that. And then if we wanted to, you could go a step further and factorize, because y is common to both of these. So we can take a y outside the bracket. What am I left with inside the bracket? What have I got to times y by to get xy squared? xy. What have I got to times y by to get y? 1. So it factorizes down to y into xy plus 1. So all of this simplifies down to that. And again, I'm not saying you would necessarily want it written like this, but it's important to recognize that they are the same thing and you can write it like that, which is what this exercise is all about, really. Seeing how we can write terms and expressions in different ways for different situations. Learning the rules of the game, in other words. Okay, what I want you to do now is to look at the exercise that continues on there. Is exercise 20, 21? Yeah. Exercise 21 on page 43. Right. So exercise 21, page 42.